Hw11 question 2. In this question, they're asking specifically about nitrogen in a bunch of different compounds. Remember that nitrogen is a very electronegative atom. It's one of the 4 most electronegative atoms, the Fonkel atoms: fluorine, oxygen, nitrogen, and chlorine. And they're written in order from left to right of electronegativity values. So fluorine is like the king, oxygen's the queen, and nitrogen and chlorine actually have the same electronegativity values. It would be like the prince and the princess. So for almost all of these, unless paired with oxygen or fluorine, nitrogen's going to have a negative oxidation state. And we'll see how it shapes up with each of these compounds. So in part A, we have lithium paired with nitrogen. First of all, you see a metal paired with a nonmetal nitrogen. That's an ionic compound. So lithium would take its normal charge lithium ion is always a +1. And nitrogen's in the -3 column. Bada bing, bada boom, that one's done. So nitrogen's oxidation state for lithium nitride is a -3. And notice that you needed 3 lithium ions in order to cancel out the single nitrogen ion's charge. Part B, we have nitrogen paired with hydrogen. Covalent compound because both of those elements are nonmetals. But which atom is more electronegative? Well, the only thing that's more electronegative than nitrogen would be oxygen or fluorine, and hydrogen's not one of those. So nitrogen would take its normal charge based on position in the periodic table, which is the -3 charge, because it's in that column, and hydrogen would take whatever charge is needed to make it add up to the overall charge of the compound, which in this case, since nothing is written to the upper right of the chemical symbols, is a 0. So we'll do a little bit of math. 1 atom of nitrogen, whose oxidation state is known to be, actually we don't even need to figure this out. In the question they only need the oxidation state for nitrogen, which is -3. But let's say you wanted to figure out hydrogens. 3 atoms of hydrogen, whose oxidation state is unknown, we'll call it X, should add up to the overall charge of the compound, which is 0. We would add 3 to both sides, and hydrogen's oxidation state works out to be +1. But that's neither here nor there, because the problem only wants the oxidation state of nitrogen. Okay, part C, N2H2. Same gig here. Nitrogen is more electronegative than hydrogen. So nitrogen would take a negative oxidation state. In this particular case, and this is a kind of a weird one. You might think, oh, it's always a -3. Well, in this case, the hydrogen is going to be a +1, and you have 2 atoms of nitrogen, which, if you do the math here, you have 2 atoms of nitrogen whose oxidation state's -2. When you add that together with the 4 atoms of hydrogen whose oxidation state is +1, that'll add up to the overall charge of the compound, which, since nothing is written to the upper right, is neutral. It's 0. I admit that that's a little bit of a goofy one. In this case, nitrogen's oxidation state is a -2. Now, for the next, let's see, 1, 2, 3, 4, 5 parts to this problem, nitrogen will be paired with a more electronegative atom, oxygen. So that means in each of those cases, oxygen will take its normal charge based on position in the periodic table, and nitrogen will take whatever charge is needed to make the sum of oxidation states equal to the overall charge. So let's look at part D. Oxygen, the more electronegative atom, takes its normal charge of -2. We can work through the math, but you might be able to do it in your head. You have one atom of oxygen and one atom of nitrogen, and overall the charge of the compound is 0. We know that oxygen's oxidation state is -2, so what must nitrogen's be? Well, if you can't do that in your head, we'll work through it. Let's call it X for now. Since nothing is written to the upper right of the chemical symbols, the overall charge is 0. So one atom of nitrogen whose oxidation state is not known, when added together with one atom of oxygen whose oxidation state is known to be -2, should add up to the overall charge of 0. We'll add 2 to both sides. And in this case, nitrogen's oxidation state is a positive 2. Part E, very similar calculation, except now we've got 2 atoms of nitrogen. So here, we'll definitely do the math. We'll call nitrogen's oxidation state X. And notice once again, the size of the charge for the overall compound is 0 because nothing is written to the upper right of the symbols. Okay, 2 atoms of nitrogen whose oxidation state is unknown, when added together with the single atom of oxygen whose oxidation state is known to be -2, should add up to the overall charge of 0. We'll do a little simplifying, add 2 to both sides, divide by 2, and we have X equal to 1. That means nitrogen's oxidation state within this compound is a positive 1. Part F. They give us the compound NO2. It's going to be really similar to the process we followed in parts D and E. Nitrogen is less electronegative than oxygen, so oxygen takes its normal charge based on position in the P table, and nitrogen will take whatever charge is needed, so that when the sum of the oxidation states is added together, it will be equal to the overall charge, which is 0. In this compound, we have 1 atom of nitrogen whose oxidation state is unknown, and 2 atoms of oxygen whose oxidation state is known to be -2, and that'll add up to the overall charge of 0. We'll add 4 to both sides, and in this compound, nitrogen's oxidation state is +4. Part G, very similar to the previous few. Now we have a non-zero overall charge. So here the overall charge is -1. But we're going to follow the same general process. Give oxygen its normal charge based on position, and we'll solve for nitrogens. We have within that compound 1 atom of nitrogen and 2 atoms of oxygen. We'll add 4 to both sides. And nitrogen's oxidation state works out to be, in the nitrite ion, NO2 minus, a +3. Part H, nitrate ion. Again, a non-zero overall charge, but the same process that we've been using. -2 for oxygen, an unknown oxidation state for nitrogen. The 1 atom of nitrogen, when added together with the 3 atoms of oxygen, should add up to the overall charge, which is -1. Simplify a bit. Add 6 to both sides. And we get positive 5. So nitrogen's oxidation state within the nitrate ion is positive 5. Part I, the N2 molecule. Notice that nitrogen is not paired with anything else. And if it's not paired with anything else, that means the electrons are shared completely equally. And if the electrons are shared completely equally, then there's no charge, even partial charges or apparent charges. So the charge in part I, or oxidation state for part I, is 0. As with all diatomic ions, the oxidation state is 0.